Hey Ellie, how are you?
I I'm good. How are you?
Can't hear you.
Um, okay, give me a second.
I'm gonna give you one sec, don't worry.
Can you hear me? Are we good? Oh my goodness. She can't hear me. Wait, can you hear me?
Yes, I can hear you.
Okay, there we go.
Perfect. How are you?
I'm good. How are you?
I'm good, thanks for asking. So today's official first lesson. Are you excited? Or not really, because you don't like theory?
I don't know because I'm on school holidays right now.
Oh, lovely. Okay,
Yeah,
that's nice. Okay, so you at least you're getting in some studying while you are on holiday.
one way to look at it.
So I
It's okay
looked
though.
at that document you sent me, right? So I'm
Yeah,
assuming we're gonna start from number one, right? Is
I
that
guess so.
you guess? So you should let me know, Ellie. Like if you're not comfortable doing something, or if you have done something and you feel like you know this already, we
Okay,
can
I'll
just
get over the things that we've done in class because if I'm going to be honest, the things that we've done in class, it doesn't really talk about the topic outcomes. It's just some things that I have to study for before I take a test.
okay,
So my end of year test is like in October, I think, and it's gonna cover all of these topics and also the previous topic from term one.
okay. That's
Okay,
quite a lot.
so
30 things
yeah,
from this term and then more things from the last term. Nah,
yeah, there's
that's too much. Thank
it's
you.
not everything, but
You have
that's
to
what we're
study
limited
everything.
to. Yeah, we kind of have to because what if we study something and we just leave
Exactly.
out the number because we're saying like, oh, it won't come up, but then it does. Then I'm
Yes,
kind of screwed.
indeed.
Um
That's what happened to me all the time.
okay, so um I've done the whole atomic theory history with all the guys from the
Mm-hmm.
past, those Niels Bohr guys and stuff.
Yeah.
Um Radioactivity, isotope, and radioisotope I've done in class. Relative atomic mass I've done. The three types of radiation I've done. Equations I've done. Half-life I've done. Decay graphs I've done. I'm up to fission and fusion.
Okay. Okay.
Yeah,
So I see. But I didn't know that. So unfortunately, I prepared a lesson for us based
that's
on number
okay
one.
because I'm gonna be honest with you. I don't pay attention in science.
Okay. That's what I
at
was
all.
thinking. Okay, so it's
I
good to start
don't.
from the
I have
beginning.
no idea what's happening in class right now. And to be honest, I hate my science teacher.
Oh,
So
okay, great
it,
stuff.
it's
Usually I've
to
never
study.
once heard a good thing about a science teacher. So I don't know, maybe it's just all of them. Maybe they are very upset about the topic they have to teach, so they are very grumpy all the time. I don't know.
Yeah, my teacher's a bit jumpy. Like he's interesting. Like he has a PhD and stuff, so I don't really know what he's doing in high school.
Maybe it's
But I
easier.
maybe it's easier, but I don't know.
Mm.
I just don't like the guy, therefore I hate his class.
I see. I see. You
So
are a typical
maybe we should restart.
stereotype.
We have time.
Yeah.
We have time.
So, yeah, I prepared like a reading piece type of vibe, because I know that you are a
Mm.
visual learner, but unfortunately I don't know how to make these things fun in a way. Like I can show you a
Yeah.
video, but that's something you can watch on your own too. Like that's not for me
Yeah.
a good way to go. So I have reading things. We can go through it again and again. I can quiz you in a way, maybe if you would like.
That's
Um,
fun.
okay, perfect. So this is a reading piece I have found. That looks quite good. It has all the details about these people that
These
apparently
weird
have a
people.
significant impact in our life, which I don't understand, but yeah.
I remember none of these guys.
Okay. So I'm gonna butcher these names unless you can correct me if you know the proper names, but I think it's
I'm go-
Democriticus.
I'm gonna butcher these names too because I
I think it's Democriticus. Not gonna lie, I think it's
I think
Democriticus.
it's Democratus.
Democritus.
I
Mm.
don't know.
Mm,
Maybe
mm, mm, mm. That makes
right,
me
right.
Critus. Critus. I feel like that's good. Okay, Democritus. Okay,
All right.
so how do you want to do this? Do you want to read? Do I read? Do we make turns reading? How do you feel?
What do you think's better?
I don't know.
Because
Because I'm still
I'll
gonna,
read. I'll read.
even after you read, I'm still gonna explain the it again. I'm gonna go through it again. So you can read
Then
it and I'll explain.
I'll read then because then I don't think you should read if gonna explain it again.
Okay, okay, okay.
All right. Okay. So Democritus 400 BCE, which is before Common Era.
Mm-hmm.
Democritus was a Greek philosopher who lived around 400 BCE. He is considered one of the earliest people to propose the idea that matter is composed of small, indivisible, divisible,
Indivisible.
divisible, divisible particles. These tiny units, he believed, made up everything in the universe. Although he had no scientific evidence, his logical reasoning and philosophical approach were groundbreaking for his time. Democritus called these basic particles atomos, okay, which means uncuttable in Greek. He theorized that if you kept cutting something into smaller and smaller pieces, you would eventually reach a particle so small that it could not be divided any further. These atomos were eternal, indestructible, and made up all substances. Democritus believed that different types of atoms existed for different materials, and that their shapes and arrangements determined the properties of substances. For example, rough atoms might create solid objects, while smooth atoms might make up liquids. However, these were only ideas and were not proven through any formal experimentation. The scientific community of his time did not accept Democritus's ideas. Influential philosophers like Aristotle rejected the concept of atoms and promoted the idea that all matter was made up of four elements: earth, air, fire, and water. Because Aristotle had more influence, Democritus's atomic theory was largely forgotten for over 2,000 years. Despite the lack of experimental evidence, Democritus's ideas laid the philosophical foundation for modern atomic theory. When scientists began exploring the nature of matter again centuries later, they built on some of his concepts, turning ancient philosophy into modern science.
Slay. Okay, so that is all for him. So, do you remember any of this in the slightest?
Yes, I remember Aristotle went in and was like, no, screw this guy. I don't think anything was made of atoms. Like, weird guy, man. Why does he talking? And so he was like, basically, what happens is there's earth, fire, air, and water. And that's what the world is made out of. I
And
don't like
then,
Democritus, and so he kind of screwed his entire theory. But anyways, I think Aristotle, he's still being talked about to this day because he's still somewhat important
Yeah.
as kind of like a rebel against Democritus. But Democritus' theory is a lot more accurate. It's not accurate at all, and like, well, actually, it kind of is, but it's a lot more accurate than Aristotle's things believing in like the four elements. So
Yeah. Okay, I see. So, but Democritus was basically the first person to believe there might be smaller things like atoms, you know? So he was basically the first one to discover it, if I'm not mistaken. Like, Ellie, don't get me wrong, right? I am very smart when it comes to theory. I'm not very smart when it comes to equations, okay? But never in my life have I done this in school. I have done this briefly, like in university. I know a few things about this, but this I'm not too good at, but I can get good at it because while I'm reading this with you, I'm basically remembering it too now. So you need to like fill me in on all the tea basically on these people and the things they have done. So basically, Democritus is the first person to discover atoms, right? Not
yeah,
discover, but like think of
not
it.
discover, but actually popularize it and actually tell people that yeah, this is a thing.
Okay, okay. And then who was the first person to discover it?
I don't know.
I thought you were gonna know. I thought you were gonna give me like
How
inside
would I
information here.
know?
Okay. Okay, so basically, let's get down to key points. Democritus. So he was a Greek philosopher, and he is
Yes.
one of the earliest people to propose the idea that matter is composed of small, indivisible parts. Okay, and then
Mm.
he actually came up with the first name because he said atomus, and it's actually atoms. So I'm assuming the first person like just based it off of that. I'm not sure because
Yeah,
like
he called these particles atomos, which is
yes.
uncuttable in Greek. So if he called it, then he probably
Yeah,
invented it.
because like it's not atoms now, it's atoms. So somebody
Yeah,
whoever like discovered it probably like based it off of that. Because that's what I'm feeling. He still remembered Democritus in a way. Okay?
I think we'll find that out as we read,
Yeah,
because
probably.
there's a whole timeline for these guys, and I have to remember that.
I shame. I don't know a lot about these guys, but I feel like they do deserve more credit. But
Do
at
they?
the same time, I don't care. Like I don't care. Like we live, we're gonna die. I don't care about these things.
Like
That's my opinion.
I don't really care if you don't agree with like Democritus, but the earth, fire, water, and air thing, that just kind of sounds kind of stupid. I don't know why people believed in that.
Like like he was. I'm assuming he was also like a scientist, or he was like
Yeah,
some.
Aristotle had brains.
Yeah, he brains, but like, why did he like say that thing? Like, he was like, it was
He
not like,
said a lot of other weird things, and people believed him. Like he said, okay, I don't quote me on this. I don't know if it's actually Aristotle, but it's probably Aristotle anyways, because
yeah,
it's pretty stupid. He said if you drop a heavy object and a light object at the same time, the heavy object will fall faster than the light object because obviously it has more weight, it has more mass, it will
yeah.
fall faster. People believed him for centuries. People people nodded their head off. People were
But
like
you know,
Aristotle, the
I would
great
feel
man.
like that's true.
But it's not, because
Wow.
gravity, it pulls down everything the same. So a couple hundred years later, some guy, I don't know which guy, maybe Galileo, but like some
Yeah.
random guy, he took two objects. He was like, Aristotle, interesting guy. Let's see if his theory is right. Took a heavy ball, took a light ball, dropped it. Guess what? They both landed at the same time. And he was
Oh,
like, this guy was wrong for centuries, and people believed him. People died believing that two
yeah.
objects, heavy and light, would fall at different speeds.
So what would actually like influence the fall? Would it be like the shape? Would it be like obviously if it's something that's built like this, it probably have like air resistance. I don't know.
I think it's mostly depend on gravity, because gravity just sucks everything down. But
No.
I don't know. I'm not a master on that. But apparently, some guy debunked that theory,
Okay, yeah,
and they were right.
true. I actually want to test this theory on my own right now because I do feel like how, how,
Really?
yeah, because I feel like
I don't know. I was thinking that too. I was like, Aristotle, interesting guy, but turns out his theory was wrong for so long.
yeah,
And maybe I should research about this, but
yeah,
I don't
maybe we
really
should
like
do some
physics.
research. Maybe in the
I don't
next
really like
class we can do
physics.
some research about that.
Yeah. Okay.
Okay, Slay. All right.
All right.
So He theorized that if you kept cutting something into smaller and smaller pieces, you would eventually reach a particle that so small it could not be divided any further. These atoms were eternal, indestructible, and made up of all substances.
Yeah,
Okay. Believe that different types of atoms existed for different materials. So he basically just believed a lot of crap, and at the end of the day, what we can say that he believed is that, well, he believed that there's four elements, and he believed that they, if you keep cutting things into smaller and smaller and smaller, they will be indivisible small pieces of Earth.
yeah, which
He
is
basically,
atom.
yeah, he basically just like got the idea of atoms like laid down for us. That's what he did, I feel. That's the basic
Yeah,
thing.
that's all he kind of did, and we're still
Yeah, that's
talking
that's
about it.
sad, actually, shame. But yeah. And
Okay,
then the next person, let's move on to, I'm gonna actually move this down because like I don't wanna read in two parts.
okay, okay. John Dalton.
Dalton, yeah.
Dalton. Okay. 1803. John Dalton was an English scientist and a school teacher who revived the concept of atoms in the early 1800s. Unlike Democritus, Dalton used scientific evidence to support his ideas. Through experiments involving gases, he noticed that chemical reactions always involve substances combining in specific ratios. Dalton proposed the first modern atomic theory based on his findings. He stated that all matter is made up of atoms, which are indivisible and
Divisible.
indestructible. Divisible and indestructible. This marked a shift from philosophy to science as Dalton relied on empirical, is it data or data?
And that's each to their own. I say data. But I
Data
think
is
I think data is
English,
like
right?
phone, and I think data is like something else. But I like to say
I
data as well. It sounds more fancy.
what do Australians say?
I don't know what you Australians say. What do you say? I think you would
What
say,
do you say? Because we base off our language from you.
I think I say, it depends. Like I said, I feel like data is for phone and data is for information. That's my opinion. So
That makes sense.
yeah,
Wait, that
logical.
actually that makes sense.
Thank you.
Okay, so data
Data,
to
yes.
back up his model. One of Dalton's key observations was that atoms of a given element are exactly the same in mass and properties. This helped explain why compounds always formed in fixed ratios. For example, water always contained two hydrogen atoms for every oxygen atom. Dalton also believed that atoms could not be created or destroyed during chemical reactions, only rearranged. This supported the law of conservation of mass and helped establish the rules of chemical combination. His model portrayed atoms as solid spheres similar to billiard balls. Although some parts of Dalton's theory were later disproven, like atoms being
Divide.
indivisible, his work marked the beginning of modern chemistry. He provided a framework that scientists could continue to refine over the next century.
Okay. Okay.
So,
So Democritus,
Democritus,
yeah,
yeah,
he discovered like, okay, this might happen. Then John Dalton went further with that, but he actually tried to use evidence. But at the end
yeah,
of the day, he got dismissed as well.
yeah. No, one of his theories are right though. He said that atoms could not be created or destroyed during a chemical reaction. That's
Only
true.
rearranged,
But
yeah.
the fact that atoms being indivisible apparently is disproven. Although I
Yes.
don't know how.
So when you divide, I think divisible is like when you divide something. So atoms cannot be divided. So one atom cannot be like split in half and be divided.
Yeah, but it can.
It can.
Subatomic particles,
Exactly. So yeah,
like protons and neutrons.
it was dismissed, but it's actually true. They just haven't had the technology to prove
Yeah.
it yet, probably. Or I don't know,
Mhm.
lots of people in the olden days, like some old people, they still have their set beliefs. They won't believe anything else. It's like propaganda. I won't fall for this. I know lots of old people are like that. So they won't believe you when you say things unless they are actually like proven. Then they will still be in denial, probably. But
Yeah.
yeah. So they are set in their ways. Um,
Mm.
So, okay, Democritus discovered, not discovered, laid down. Then he came, and then they still said no. So I actually feel bad for these people because they actually put in all the work and they now it's over.
Yeah, it was life's work, and
Yeah, and
now
now somebody else is getting all the credit for discovering something. Nah.
exactly. So J.J. Thomson,
Mm-hmm.
1897. So he was a British physicist who made a groundbreaking discovery in 1897, the electron. His experience with cathode ray tubes revealed that atoms were not indivisible as Dalton had believed. Instead, atoms contain smaller, negatively charged particles. Thomson's discovery of the electron was the first evidence that atoms had internal structure. This was a revolutionary idea at the time. His work showed that electrons were much smaller than atoms and carried a negative electric charge. To explain his findings, Thomson proposed a plum pudding model of the atom. In this model, the atom was imagined as a positively charged pudding with negatively charged electrons scattered throughout, like raisins in a pudding. It was an attempt to explain how positive and negative charges balanced within the atom. Although the plum pudding model was later proven incorrect, it was an important step in development of atomic theory. It introduced the idea that atoms were composed of both positive and negative components. Thomson's work earned him the Nobel Prize in Physics in 1906. His research opened the door for future scientists to investigate the structure of the atom further, ultimately leading to the discovery of the atomic nucleus and quantum theory.
It's like,
Oh, so this guy got somewhere.
yeah, he got something done, but it wouldn't have been possible without the other people. So, like, I do understand like why we have to learn about all these people, but still, I don't know. I don't know. It's
Hmm.
probably good to know. Um, yeah, so that's I think that was a good idea for him to use the plum pudding model. Like that was a good like visual aid for us to because hearing that I can see what his vision was, but
Yeah.
it was not completely correct.
Yeah, his vision was a bit
Like it was
silly.
there, like we have to give him the credit. Like
Yeah, I mean he won a Nobel Prize. I mean, I didn't win one, so who am I to say he
yeah.
was wrong?
And also
But
like it's easy for us to judge because we already know all these things now. Like if we were just as oblivious as them then, we would like be like, yeah, this is like eating, it's making
exactly,
sense.
my guy didn't even know about protons.
Yes, come
Oh,
on, come on. Let's give
okay,
him the benefit of the doubt. Okay.
okay.
All right. Now now we have Ernest Rutherford.
Rutherford,
Rutherford, yeah.
Rutherford, Rutherford. All right.
I think so.
Ernest Rutherford, a New Zealand-born physicist, made a major contribution to atomic theory with his gold foil experiment in 1911. He fired positively charged alpha particles at a thin sheet of gold foil and observed their scattering patterns. Most of the alpha particles passed straight through the foil, but a few were deflected sharply. This unexpected result led Rutherford to conclude that atoms must be mostly empty space with a dense, positively charged center, what we now call the nucleus. Rutherford's model Rutherford's model proposed that the atom had a central nucleus containing all of its positively charged and most of its mass. The negatively charged electrons, he believed, orbited this nucleus like planets around the sun. His findings his findings disproved the plum pudding model proposed by J.J. Thomson. Rutherford's nuclear model introduced the idea that atoms have a small but powerful center that determines much of their behavior and reactions. Rutherford's work laid the groundwork for future discoveries, including the identification of protons within the nucleus and the work of Niels Bohr, who refined the model of atomic structure based on energy levels.
Okay. Slay. So he made gold foil and he fired positively charged alpha particles at a thin sheet of gold foil. So basically, is it like, do you know about this experiment or not?
Kind of. Because gold foil, the alpha particles, alpha is helium,
Mm-hmm.
so it contains two possibly like charged kind of protons.
Yeah.
And if it bounced back, which means if it bounced back, which means the gold foil was probably negatively charged. But I think the main part that I remember from this is that the reason why he came to the conclusion that there was a strong center was because when he fired the alpha particles at the thin sheet of foil, the
Yeah.
surroundings, if it was the plum pudding model like Thomson proposed, then the surrounding protons or everything would just bounce back.
Yeah.
But only as the center part of it bounced back, which means there was a higher concentration of protons that actually hit the foil. Therefore, he believed that, oh, maybe the protons, the not protons, but like just the positively charged subatomic particles, they weren't scattered around like the plum pudding model kind of,
Yeah.
you know,
I see.
theorized up.
I
But
see.
rather they were all
Bunched
kind
up.
of focused, bunched up, concentrated in a specific area.
Yeah.
Therefore, some particles they just kind of shot through, but some particles they had to bounce back.
Okay. Okay, big slay. All right. But you know what my main thing is like going through this, like I just don't know how scientists could be like so creative, like using like everyday objects, like using things like that. Because why would he think of using gold foil? Like I
Yeah,
would
why
never.
would you pick gold foil
I
out of
would never
everything?
like think of that. I would never. And I feel like
Not
my
that.
brain would never be smart enough to like think of like things like this. Like I wouldn't wonder like what is this made of? I wouldn't wonder. I wouldn't care. Like it's
Yeah,
here.
we just let it be.
Yeah, I have it. Like I don't care really. Um so he proposed that the atom has a central nucleus containing all of its positive charge and most of its mass. The negatively
That's
charged
true.
electrons, he believed, orbited the nucleus like planets around the sun. So the one part is true. The second part,
I wouldn't say orbited.
yeah, I don't think orbited as well. They are there. They are like situated
Yeah,
basically, I think, right?
they're not like structured in a specific way, and like definitely not planets around the sun. But
Yeah.
I get his vision because obviously at the time this finding was like really big,
Yeah.
and I get why he would think that because obviously the plum pudding model was, well, not true at all.
Yeah. It is definitely not true at all. But basically, like when we go back, like it said like here, he one of them like discovered like sort of a nucleus. Where
Mm,
was that? Which one was it?
not sort of nucleus.
Yeah, like where was that? I reread it. We read it previously now. Or was it in the first one? But that's
I don't think it
basically
was in the first one because Democrats did nothing. Democrats just looked at something and decided that, oh, we can cut this thing in a million pieces. I mean, I can do that
okay.
too.
Okay, we are slaughtering Democritus right here. Where is that one where it said like he discovered like sort of basically a nucleus?
I think it was, I think it was I think it was still
Still here.
I think it was Thompson. It was still Thompson. Like it was
Hmm.
still the
Yeah, yeah,
guy.
yeah. Internal structure.
Yeah.
Okay, so that was a good start basically. That was the part this is where I feel like things came together like
Mm.
more. Like besides the plum pudding model shame, that was not good, but
That was a bit off.
he gave
Could
us
be
the
better.
idea of a nucleus. Like when I first started
Yeah.
doing like I didn't do chemistry, but I did biology in school. So when we learned about a nucleus, I was like really? A
Did you
nucleus?
do
And then there's
university?
a sorry?
Did you do chem in university?
Yeah, I had it as a subject for a semester. So I did that. I think I
Oh.
had like it. I studied for 4 years. In that 4 years, I think I've had it like three times probably. But yeah, it wasn't an enjoyable time for me.
Mm.
Especially like the equations. Like I told you, you're very lucky that you can have the equations down and that you're struggling with theory, but you're not really struggling. It's not interesting to you, so it doesn't
I
catch
just
your
hate it.
attention. Yeah, it doesn't catch your attention. Like, because I can see
Mm.
that you are very smart. Like, if you wanna, you can, but you don't wanna right now. Because
I don't want to.
I know the vibes. Okay. So yeah, basically, Thomson got down the nucleus, not down, but he basics. He gave us the basics for nucleus right now. And then this guy, he went further into that. And I was
Mm,
never like thinking like, because like when I first started doing like biology and I was like, okay, like we have atoms, then we have cells, and cells is and atoms are like same basically because it's the smallest living thing, and then we have the smallest particle. Like atoms are the smallest thing you can find, right? You can't find any smaller.
mm,
So when we had a cell, like in the cell also has a nucleus. Atoms also have nucleuses. Why are these things so in depth? But it also just shows like we everything was created with such purpose and such like thoughtfulness, basically. So
mm.
like even the everything is like the smallest living things. I can't believe it sometimes. It just baffles me sometimes.
Yeah. Okay.
Mm-hmm.
Mm,
Okay, so Radford's work laid the groundwork for future discoveries, just like all of them has done previously.
mm.
Mm.
All right. So Niels Bohr, 1913. So Niels Bohr was a Danish physicist who improved on Rutherford's model of the atom. While Rutherford introduced the idea of a nucleus, Bohr proposed that electrons move around the nucleus in specific paths or energy levels. Bohr's model was based on quantum theory. He suggested that electrons could only occupy certain allowed energy levels. They could jump between these levels by absorbing or emitting specific amounts of energy, usually in the form of light. This explained why atoms emit light at specific wavelengths, a phenomenon known as atomic emission spectra. Bohr's model could accurately describe the behavior of hydrogen atoms and provided a foundation for understanding atomic behavior. Bohr's work marked the beginning of quantum mechanics in atomic theory. He showed that classical physics couldn't fully explain the behavior of electrons in atoms. Instead, electrons behaved more like waves than particles in certain conditions. Although this model was later refined, Bohr's contribution was essential. His work helped explain physical bonding, atomic energy, and the periodic behavior of elements. He won the Nobel Prize in Physics in 1922 for his contributions to atomic structure and quantum theory.
So what is your opinion about Bohr? Good, bad?
Bohr, to me, Bohr didn't really do anything.
But he won a Nobel Prize though, because he explained why atoms emit light at specific wavelengths. Like that's a new thing.
So, that doesn't do anything.
Okay, okay.
He
So do
didn't
you
make a
think that's
model, he
not
just said
worth
this
like
this
a
is light.
it's not worth a Nobel Prize in your opinion?
Yeah, I feel like the guy who scroll up a little.
This one.
I feel like this guy should have gotten the
I also feel
Nobel.
like he has been one of the most like he made more groundbreaking discoveries than the others.
Yeah, he didn't do anything. I feel like
Because
this guy did.
he
Bohr didn't do.
disproved the plum pudding model. He also
Yeah,
he proposed they have a nucleus. Slay, okay, he already has two more than the others. I feel
yeah.
like
He already did so much more, and he didn't get anything. But then this guy
yeah,
just said he looked at the electron and said this produces light, and he got a prize that is made out of gold and like millions of dollars.
I feel like the people have been falling for some sort of propaganda and they just, I don't know, they were biased or something. Because, like, I also feel like Rutherford has been the most influential in this journey up until now. Like,
Yeah,
obviously, I don't think he would be able to get here without the previous guy's work because he would probably also get stuck at that foundations and beliefs and things like that. It's just because they have done the previous groundwork that he can build off of that. Everybody's building off of each other right now.
yeah.
But Bo, I just feel like, okay, it's basic. It's basic. Radford is much better. But
Mm.
they said he was a Danish physicist who improved on Rutherford's model of the atom. So he improved it. But I
Yeah,
don't
but
think
what
he
did he
bas
do?
yeah, I don't think he improved. I think he added like it's like when
Maybe
you
just
make
elaborated
coffee.
on the things that Rutherford got too old to elaborate on. So,
I feel like it's when you make coffee. Like coffee, you can drink it without sugar. He's just adding some sugar. Like you don't need the sugar,
mhm,
but you can add it, you know? It's just like
yeah.
additional information that wasn't really groundbreaking. It was just, I don't know. I can't explain it. I don't know. I'm a bore hater, basically. I feel like he's done nothing.
Okay.
So that is all the scientists that you have mentioned in that document, if I'm correct. Or was there one more?
I can't remember.
Me neither. I think it
Let's see.
is. Hmm,
Yeah, that's it.
that's it, yes. So, okay. That is that for the four people, but I feel like we should actually also go in depth, like to the actual part, like what's going on after this. But for now, we'll just stick with this. I was thinking if, oh, okay. If you wanted to, I'm first gonna share my screen for another document I have, right?
Okay.
But we can go through this together and just like highlight the important parts for you. Maybe you can like print this out and just have, or I can summarize it for you too. Like make it smaller
Mm,
parts. Like if you just want to know the basics, not everything, because like all of this is just unnecessary information technically. But I wanted to give you like a background of how things were and what happened in the stories, you know? Because obviously I
yeah.
can tell you like Democritus, he has done this and that, but I wanted to like just give a background of how he came to this conclusions and things like that.
Mm,
So I also have this one right here. If it's gonna share now eventually.
yeah.
All right. Okay. So this is another document. It's also like there might be some repetition of information, but
Mm,
I wanted us to just have a look at this as well. So this is just a shorter version with a few questions, not a lot. But I was thinking while I was doing this, I was thinking like if we look around us, everything we see, like our computer, our phones, everything is made up of like atoms. And it was, I don't know, it was just like mind baffling at the time when I was thinking at it. I don't know if I was sleep deprived or something, but um we know this because of these people. Even though some of them like made stupid discoveries, some of them said stupid things or whatever, they like laid foundations, and also without them doing saying these things and other scientists proving them wrong, we wouldn't have gotten to this point where we are now, probably at the same pace. Because like if we
yeah.
left it all to Rutherford, he would probably discover this but he would take a longer time to make the same discoveries he has made without Democritus and these people. So, like, yeah.
Yeah.
So, we're gonna go through this now, but can you tell me, like, just a quick recap? What do you know about atoms? Like, everything you know about atoms. Can you give me, like, a quick recap of what you know?
Of what I read or what I know.
I don't know. I don't know.
Do you want me to give you a recap of what we just read, or do you want to
Oh,
give you
no,
a
no,
quick
no, no. I
recap of
want you to
everything
give
I
me a
know?
recap of what you know about atoms.
Is this so that you can teach me things that I don't?
Basically, yeah, I want to hear what you have. But obviously, I know that you
Okay.
know this. I just want you to like, I want to hear your thoughts.
All right. So, obviously, Democritus, the guy, Atomos, never really did anything, never really proved anything. He just kind of came up with a concept, died, and took us basically centuries and centuries later, because the next big step was in 18 something, 1800s.
1890.
But this guy was did this even before, like, even for common era, even before
Yeah.
Christ was born. So basically, the atoms, everything's made of individual atoms. Um, inside there's three parts, so neutrons, protons, electrons. Electrons practically they weigh like zero point 0.0 blah 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 blah. But then scientists they were like, okay, such a small mass, we'll call it nothing. So
Mhm.
that's why they always have the little minus sign.
Yeah.
So let's have a negative charge. Protons, they have a positive charge. They practically weigh they're practically the mass of the
Hmm.
element. So protons and electrons, they have the same number in an
Hmm.
element. So there's like two electrons, there's two protons. Neutrons, however, they can have more. They can their numbers can increase or decrease. It can be higher than protons. It can be lower
Yes.
than protons. Normally, when it's higher, means it's unstable. Therefore, it's an isotope. And when it gets to a point, it becomes radioactive. So that's a whole other thing.
Yeah.
What else do I know about this? Atoms, they are the basis of elements. Elements can come together, and the main thing the elements they want to do is that they want to form a full shell. So full shells are like 2 and 8 and stuff like that. And normally when they come together to form a full shell, it can be either an ionic compound or a covalent compound.
Mm.
So what else? Oh yeah. So on the periodic table at the end of the last group, the final column, 8, like group 8, they have a full shell, therefore they're very unreactive, they're unresponsive, they don't really react to anything. That's why you want to make something that's stable, that's secure, that won't like set off any chain reactions. You would normally use the one at the end. Very common example, syn rock, which is synthetic rock, is
Yeah.
made to dispose nuclear waste, and the gas it is made up of is argon gas. And argon is at the end of the periodic table, has a full shell, therefore it won't be reactive, won't react with the nuclear waste, won't create like Chernobyl 2 and stuff like that. I think I could go on, but off the top
Yeah.
of my head, that's all I can base off of. I say something and then I remember another thing and I just say that thing as well. So
But I feel like you're very passionate about it, the way you talk about it. So
I
that's,
am passionate about it.
you love it. That's good. Okay, you just don't love it. I do understand, like, you are a math girly. You are not a theory girly.
Yeah,
For
I don't like
me,
this.
for me, it's different. It's different completely. I won't ever in my life, never, you won't catch me being a math girly. Never. Never in my life.
Oh,
Never. Never. I wouldn't. Like, I'm accountant girly too. That's the only math I'll do. I'm just not a math girl.
counting?
Accounting. I love accounting.
Accounting. Okay, okay, that
Mm,
makes sense.
mm. Yeah.
Yeah.
Okay.
Oh, it is. I like math. I like numbers. I like moving them around and see what they
I
do.
know. I know you are weird like that. I can't do that.
Thanks.
That's a compliment. I
Oh,
could I
okay.
wish I could be you. I couldn't. Like Ellie, that's the biggest compliment. Like if you are able to do math, you are a winner in my eyes. Really you are, because I can't. For me, I won't be able.
That's
Like
okay.
accounting, it's like it's lovely. Like moving that numbers around. But I do get frustrated, like when things don't balance, or when I can't like understand something, but then later I'm like, oh, and then I'm so mad at myself for being stupid for not thinking of that. So I don't know. I don't maybe
Do
I'm
you do profit and loss sheets and income statement as accounting?
I love it.
And you do balance sheets and stuff like that? Oh, I hate
Yes.
that stuff.
Oh, I
I
love
take
it.
I take commerce.
I want it to balance. Like it's for me so nice to like figure out
You
why
want
it's
it
not
to balance the
balancing.
balance sheet. Of course it's gonna balance. You don't balance it, there's something wrong.
Exactly. But do you know, like, I know it's like sounding like so easy, like just balance it, but it's like, no, there's like lots of mistakes. Obviously, when they give you like the example, lots of things have been left out, or somebody has made a critical mistake, and you have to go and look at the books and like try and figure out like what's wrong here. I like
Oh
that.
yeah, I don't really like that either. I don't really like looking at assets and liabilities. I don't really want to calculate gross income or like
That's
net
my thing.
income.
And I love like giving the feedback, like from previous years, percentages with this year's percentages. I love doing that. Like that, I could never fail. I could never fail. I always got full marks there because that is the best. That's the easiest.
And I'm weird.
That's lovely. I had to. Like it's basically just comparing things, and then lots of students would get it wrong, and I couldn't understand why they would think that's the hardest part. But it's just because they were uninformed, and like no matter how much
Yeah.
I tried to inform them, I'm like, guys, come on, it's not that hard. No, nobody would listen, so it's okay, it's fine.
Mm. Oh, wow. Who knew? I take commerce at school as well.
I was what?
I take commerce at school, so I had
Mm,
to do this for mid-yearly.
I see. Okay. Right. So I basically had this. It's like a recap in a way.
Yeah.
So
Mm-hmm.
around 400 BCE, there was no science the way we know it. But a philosopher named Democritus had an idea. He said, "What if you kept cutting a piece of cheese in half again and again? Wouldn't
That
you?"
is not what he said.
Exactly. Wouldn't you eventually reach a bit so small that it couldn't be cut anymore? He called these tiny bits atoms, which meant uncuttable. Okay. So the key points is there was no experiments, it was just thinking. He didn't like actually do something, he just like, what if? So atoms were eternal, invisible, and made up of everything. So was Democritus a scientist, in your opinion?
No,
No.
he's a
Okay.
philosopher. He had an idea,
He had an
but never
idea.
got anywhere with
It's
the
just like
idea.
us. We could also have an idea, but our names are not going to be mentioned in history books, but it's okay. And
Hmm.
then what's the difference between a guess and a experiment?
So, what was he asking me? A guess is something that you kind of come to the conclusion to based on what you know. So, a guess is something that it's kind of hypothetical.
Yeah.
It's just something you randomly kind of come to a conclusion on, but there's actually no evidence to back it up, or else it will be a claim or a statement.
Mm-hmm.
An experiment is when you actually go ahead with that guess and you perform it and you test to see if your hypothesis is true or not through an experiment. So you use whatever you have to best conform to the guess, and then you'll see if your guess was right or not.
Mm-hmm. Okay. Yeah, that's what I was also thinking. Like, I guess it's just like a thought. It could be luck. But an experiment is where you actually take evidence and you present it to me. Because, like, obviously, if you tell me something, I'm not just going to believe you unless you back it up with proof. And it's proof that is actual, I can rely on that. It's not something I
Yeah.
have to wonder about. That's basically the difference, you know? It's like evidence. Because an experiment
Mm.
provides evidence to you. You had to do something to actually see that. Okay, so the early 1800s, the school teacher and a chemist, he brought back the idea of atoms, but this time with science. He studied chemical reactions and noticed patterns. He came up with the first real atomic theory. So, key point of his theory is that all matter is made of atoms, which is correct, right? Mm-hmm.
Yes.
Why are you so
Yes.
unsure? You're scaring me. It's
Yes,
correct.
yes. All matter is made of atoms. Yes.
Okay, okay, okay. Atoms of the same elements are identical. True or false?
Is this true or false or key points of his theory?
This is key points, but like this is what key, well, wait. This is a key points of his theories, but I'm asking you if it was correct or if it was not. Like, is this accurate in today's life of what you know now?
Are they identical? Probably not.
I don't th
Because let's say you have uranium, two uranium elements. First of all, the things that could be not identical are the electrons and how they're structured. We still don't know the formation that they move in.
yeah.
We still don't know how they
Yeah.
move, where they move to. Do they even move at all? Stuff like that. And second of all, are they identical? Because there's different isotopes of uranium.
Mm-hmm.
There could be uranium like 230 something, 235, and there could be uranium 237. It
Exactly.
varies, it differences in neutrons
Mm.
if we're talking about what's the difference in these two isotopes. And 10, the one with like the more neutrons would be more radioactive, which would then be a whole other difference kind of
Yeah.
thing.
Like
But
they still have the same name, but they are different, like in their
yeah,
reactions and
yeah,
the things they might cause.
the notation's different because the components are different. So
Hmm.
identical, probably not,
Okay.
because say identical twins, there's still going to be differences about them.
Indeed. Okay, perfect. So that's we achieved that now. His third one is that atoms join to form compounds in whole number ratios.
What does whole number ratios mean?
It's probably like 2, 4, 6, 8 whole numbers, not uneven numbers.
Oh,
Hmm.
they do join to form compounds,
But is it
but
whole
it,
number ratios?
it's to get a full outer shell, which I don't know if that's whole number ratio or not.
Okay, yeah, that's true. Like, is it a whole for the shell or is it a whole for the amount?
It's
So,
it's a whole for the shell, which varies in amount.
It does vary as amount, but usually when you talk about whole numbers, you talk about numbers that are like 2, 4, 6, 18, 12,
Yeah,
14, something like that. So it's probably not like all of them are not whole number ratios, if I'm correct. I don't know how many elements and things are in the in atoms
periodic
and
table.
things like that. I'm
Oh.
not sure. I didn't study the periodic table like that. Like, well, I
Mm.
did. I can't remember it. Um, so your opinion? Yes, no, half?
I would ignore the whole number ratios thing.
Mm-hmm.
I'd say they do form compounds
Okay, they do form
because they do.
compounds.
They
Okay.
do form compounds, but whether they form whole number ratios or not, I'm still not expert on that.
Okay. Atoms are not created or destroyed in chemical reactions,
That's true.
which are true,
He got
yes.
he got that down. He got that
Yeah,
down.
yeah, yeah. He ate that. Okay. Now, in 1897, a scientist named whatever made a discovery that changed everything. He discovered the electron, a tiny negatively charged particle inside the atom. This showed that atoms weren't solid balls after all. So his
Mm.
model, known as the plum pudding model, he thought atoms were like a pudding of positive charge with negative electrons scattered like raisins. So, why was this shocking at the time? Because atoms weren't solids anymore. Okay. So like this was
Really?
shocking to everybody because everybody thought it was just like a solid ball, and now it's like confirmed that there's things inside of that, not just a solid ball. There's more to it.
Mm.
So that is why people were like, "Oh yes, give this man give him like a
Nobel Prize.
yeah." Was he the one who got the Nobel Prize? I'm not completely sure now.
Yeah,
Yes,
definitely not
yes,
Rutherford.
yes. He no, it wasn't Radford. Like we feel like he
No,
was the
that guy
guy, but
didn't
he
get
didn't get
anything.
anything. Yeah. So that's what people are like, yeah, like give it. Okay.
Okay,
Then we
interesting.
Yes. Then we have Ernest Rutherford, and he discovered the nucleus. So now imagine you shoot tiny bullets at a piece of gold foil. What do you expect? Most should bounce back, right? That's what Ernest Rutherford thought when he did this famous gold foil experiment in 1911. What he found is that most particles pass through, a few bounce back sharply. Conclusion: atoms are mostly empty space with a dense positive nucleus. So, like you said, it was like all bunched basically in or focused in a certain spot, and that is what he was thinking too. So,
Yeah.
if atoms are mostly empty, why don't we fall through floors? It's because electrons move fast and repel others. So that is obviously something that you already know, but it's just we're going through
Mm.
some basics. Now we have Neil Bohr energy levels. In 1913, he built on Rutherford's idea. He added something important: energy levels. He said electrons don't just fly around randomly, they move in a fixed orbit like planets around the sun. So, key points: electrons orbit in fixed paths. Each orbit has a specific energy, and electrons can jump between levels by absorbing or releasing energy. Okay? So, he doesn't like believe that they orbit, but they believe that they orbit in a fixed path, basically move in a fixed path. Do you agree on
Um,
that?
I don't think he got that right
Yeah, I don't
because
think you got that right either. Like, that was something.
how does he know? He doesn't know that. There's no fixed paths.
I don't know. How
And
did he discover this again? What did he say?
why did he didn't do anything?
He didn't do
He
anything
just
like
he didn't do anything. He didn't shoot anything at gold foil. He didn't plum
exactly.
pudding. He just
He was like Democritus, and I was basically just saying things. Like he didn't have any
yeah.
valid evidence to back that up.
Yeah,
So
didn't really do anything. So I don't know why he said that.
yeah, because like in the previous document we just did, he said that, is it this one? Yeah. He said that electrons, he suggested. He didn't do anything.
Yeah.
He explained. He didn't do anything else. But I
Mm.
don't know why he thought of that. Like, what made him think of that? Like, obviously, he had to sit around and think of something and made him think of that. It made him come to this conclusion. But I don't
Yeah.
know what. They need to
Mm,
tell us. Hmm. Yeah, no. No solid proof, thank you. I do not agree at all.
mm.
Okay, so why do you think this idea helped explain how atoms give off light?
Because they have different energy levels.
Okay.
I feel like it doesn't matter.
Like, is which theory is the one that like oh no, but that's a spectrum, I think, or something like that. When it rains and there's a rainbow, the stuff. Is it not
That's
something to do with that? That's something completely different, right?
yes.
Mm-hmm. Okay. Because that was the first thing I came to mind to think of now, but yeah. So scientists kept asking questions, and soon people like Erwin Schrödinger and how do you say his
Heisenberg.
name? Do you know these?
Erwin Schrödinger was more popular as a philosopher who came up with the Schrödinger's cat scenario. Do you know that?
Mm-mm.
Schrödinger, oh, this is so fun. Schrödinger's cat is kind of ethical situation where there's this box and there's this cat, and inside the box is a vial of poison.
Okay.
This vial of poison, when you close the box up with the cat inside, it could explode anytime. It will kill the cat instantly.
Yeah.
But if you don't open the box, you'll never know if the vial of poison exploded or not. It's a 50-50 chance.
Okay.
So as long as the box is closed, the cat can be considered both alive and dead.
Hmm.
And the only way to know that if it's still alive or if it's dead because of the poison is to open the box. So that's the moral thing. If you don't do something, then it could exist in multiple universes
Yeah.
in different situations and it could have different results. But you actually do it, then you'll see how the result turned out and it will be confirmed. But as long as you keep a closed door on any opportunities, on any things that you aspire to be or want to pursue, that closed door could be endless possibilities that will never actually be confirmed unless you actually open the door. So that's his kind of philosophical thing.
Oh, that's actually beautiful. I love that.
It is.
That's great. Okay. And then the second person's name, that's actually one is it Werner
Werner
Heisenberg?
Heisenberg. Yeah.
Okay. So he discovered something new. Electrons don't follow near orbits. Instead, we can only guess where they probably are. This
It's
is the modern atomic theory. So
mm,
the modern model is electrons move in a cloud. We talk about orbitals, areas where electrons are likely found based on quantum mechanics. Okay. So a quick recap. Let's go over the six scientists and their model. So, opinions is that Radford is the only one who actually made something, who added something valuable, in my opinion. But also, without the others, he won't be able he wouldn't be able to achieve this. What is your opinion?
that's true.
You believe that too?
I think yeah, Rutherford he did contribute a lot to the atomic kind of theory and the
Mm.
atomic world. He actually came up with electrons, which we all know is a very important part in chemical reactions today and in just the whole elements thing because everything is based off of electrons. So beta
Mm.
particles are based on electrons, um, compounds are based on electrons, reactions are based on electrons. Electrons are the things that react and what kind of makes the whole chemical and matter thing. So
Mm.
yeah, he definitely did a lot. But at the same time, I feel like he wouldn't have come as far as he did, or he wouldn't even get the chance to do what he did if Democritus didn't come up with his vague idea
Yeah.
of atomos.
Yeah, that's what I'm saying. Like nobody would like ever come this far. Like if probably if Democrats didn't think of this, I don't know how long it would take for them to actually like think somebody else would think of it if he didn't think of it. But like
Yeah, I
because
feel
he
like
thought of it, somebody else could build on that.
yeah, it's true because their whole theory was based of debunking one another until it
Mm.
couldn't be debunked anymore. And I think in the future, near or far, one of them will still get debunked. Maybe they'll finally figure out where electrons are. Maybe
Yeah.
they'll finally figure out how they move. But at this time, even Heisenberg, a lot more recently now, he's still saying that we can only guess where they are and the locations that they are most likely found, not where they
Mm.
are found.
Yes. Well, there is still space for somebody to discover lots of more things. And I feel like you, like genuinely, I feel like you would be someone who would like discover these things because you are like very passionate about it. And I feel like you would like try and debunk these ideas and like, no, that's not true. And then you would like actually present
I
something.
would debunk them, but I
Yes.
don't know how.
I feel like you are smart enough to like think of these things and do experiments that are, you would like think of something like gold foil. I feel.
Oh, I would not think of God. I don't know why he chose God for that of everything.
I feel like you would do something creative like that, definitely.
Mm.
Hmm.
Oh, thank you.
Okay, Ellie, I'm gonna stop us now because I have a class after us. But I please
That's all
want you
good.
to send me some feedback. Like, tell me what I should do, what you want else, if there's something else you want to do, if there's
Can I
anything,
ask
you
you a
can send
question?
me a message. Yes.
Do you like chemistry?
Do I like chemistry? No. Do I teach it? Yes.
You teach chemistry, but you don't like
Like,
it.
yeah, like with Sam like asked me like if I'm able to please do it. And then I said, yeah, but it's not like something I'm passionate about, you know.
Do you teach any other people chemistry?
A lot of people chemistry.
Do you teach a lot of other people
Oh no,
about
I
chemistry?
only teach one other student chemistry.
Oh,
Hmm.
how old are they?
Sorry?
How how old are they? Are they in high school?
They are 17, if I'm not mistaken.
Oh, that's so sad. 17 doing chemistry. That's probably hard.
Yeah, it
Oh,
is.
well.
All right. But I'll see you,
Well,
Ali.
thank you.
Please do send me feedback. If there's anything you want to change, like be completely honest. Like this is your education. You need to be able to tell me like don't do this, and things like that, okay?
Oh,
I'm
I'm not really
completely open to
straightforward like that.
criticism. I'm open to criticism, okay?
Okay, that's
All
all
right.
good. Thank you.
I'll see you, Ellie. Have a lovely
See
evening.
you. You
Bye.
too.